Hi guys! Today's lesson, Points, Lines, and Planes, is probably one of the most important lessons in the course. Alright, let's get to it. Today's learning goal is that you will be able to understand and use the basic terms and postulates of geometry. Take a minute to look over the scale and figure out where you are right now. In geometry, points, lines, and planes are considered undefined terms. We will use these terms to build the definitions of all other figures in geometry. Even though these undefined terms don't have an exact definition, it's important for us to have general descriptions of their meanings. A point indicates a location and has no size. We use a dot to represent a point. When we name a point, we use a capital letter. This is point A. A line is represented by a straight path that extends in opposite directions and continues forever. A line has no thickness and it contains an infinite number of points. We use a double arrowhead to represent a line. When we name a line, we can use any 2 points named on the line or a lowercase letter. So here, this could be line AB or line BA, or we could also call this line L. A plane is represented by a flat surface that extends without end and has no thickness. A plane contains an infinite number of lines. Think of a plane as being the surface of the ocean or a large field. When we draw a plane, we use a quadrilateral to represent that plane. When we name a plane, we use any 3 non-collinear points, such as point R, point T, and point S, or we use a capital letter. So here this would be plane RTS or plane V. Let's take a look at collinear, non-collinear, coplanar, and non-coplanar. Notice the collinear has the word line in it. So collinear means points that are on the same line. Point P, point Q, and R are collinear points. Non-collinear means not on the same line. So point X, Y, and Z are non-collinear points. Coplanar, notice the word plane here, means points that are on the same plane. So points A, B, and C are coplanar points. Non-coplanar, not on the same plane. So while points D, E, and F are on the same plane, points D, E, F, and G are not on the same plane, so they are non-coplanar. In example 1, we're going to name points, lines, and planes. For part A, what are 2 other ways to name line QT? Well, remember, we can use any 2 points on the line. They use point Q and point T. So let's use, how about point N and point Q for line NQ? Don't forget to use the symbol for line, so I know you're talking about a line, not a segment or a ray. The second way we can name line QT is with a lowercase letter. Look at little m. Next to line QT, this can be called line M. Next, what are 2 other ways to name plane P? Remember, you can name a plane with a capital P, capital letter, which is what they've done here, or with any 3 non-collinear points. Since we have point V, point R, point Q, and point S on the plane, let's choose 3 of them that aren't on the same line. How about V, R, and Q for plane VRQ? Now, let's choose 3 other non-collinear. So how about V, Q, and S for plane VQS? Lastly, what are the names of 3 collinear points and what are the names of 4 coplanar points? Collinear on the same line. So here we have point R, point Q, and point S on line L. And 4 coplanar points, coplanars on the same plane, we have point V, point R, point Q, and point S. So points V, R, Q, and S are coplanar. Take a minute, pause the video, and try number 1. Okay, I hope you paused the video because I'm about to give you the answers. So looking at part A, they want to know what are 2 other ways to name line RS. Again, here's point R, here's point S, so this is line RS. Remember, we can use a lowercase letter next to the line, so we'll call this line L. We can also use 2 points named on the line. So here we have point R, point Q, and point S that are on the line, so we could name this line RQ. Again, Don't forget to use your line symbol so that I know you're referring to a line, not a segment or array. Part B asks, what are two more ways to name plane P? All right, so we want to use three non-collinear points. So again, point V, and this time how about point R and point S? We will call this plane V, R, S. Remember that when naming a plane, order doesn't matter. So let's just switch the order of three of the points that are on our plane. So how about plane Q, S, V? Part C asks, what are the names of three other collinear points? Again, collinear is on the same line. So since last time we used line L, we used points R, Q, and S as collinear points, let's use the points named on line M, point T, point Q, and point N. And finally, part D wants to know what are two points that are not coplanar with points R, S, and V. Well, here's R, here's S, and here's V on plane P. So we want the 2 points that are not on plane P, which would be point N and point T. So, how'd you do? Are you ready to move on? The terms point, line, and plane are undefined because their definitions would require terms that also need defining. You can, however, use undefined terms to define other terms. A geometric figure is a set of points. Space is a set of all points in 3 dimensions. Similarly, the definitions for segment, ray, and opposite rays are based on points and lines. A segment is part of a line that consists of 2 endpoints and all the points between them. So here are my 2 endpoints. Here are the points between them. When we name a segment, we use the 2 endpoints as its name. So here we would call this segment AB, or we could reverse the order and call it segment BA. A ray is part of a line that consists of 1 endpoint and all the points on one side of that endpoint. A ray extends forever in one direction, and it contains an infinite number of points. When we write a ray, we use a single arrow to represent the ray. When we name the ray, we use its endpoint and any point named on that ray. Since A is the endpoint and B is the only point named on this ray would have to be called ray AB. Opposite rays are 2 rays that share the same endpoint and form a line. Opposite rays look like a line with points or a point on them. We name opposite rays by their shared endpoint and any other point on each ray. So here, since C is the point between points A and D, we could name this ray, ray CA, and we could name this ray, ray CD. Ray CA and ray CD are opposite rays. All right, let's name segments and rays. For part A, what are the names of the segments in the figure at the right? Well, the first segment I see would be segment DE. The next segment is a little longer, segment DF. And the third segment I see would be segment EF. Remember, in a segment, order doesn't matter, so I could also call this segment segment ED, I could call this segment segment FD, and I could call the third segment segment FE. Let's look at part B. What are the names of the rays in the figure? Remember, a ray is an endpoint and any other point named on that ray. So let's start with point D and head in this direction towards points E and F. I could call this ray either ray DE or ray DF. The next ray I see starts with endpoint E, and I could head to the right towards point F for ray EF. Next, I could start again with endpoint E, but this time head to the left towards point D for ray ED. And the final ray on this line would be starting with endpoint F and heading towards the left towards points E and D. So let's call this ray FE. Don't forget to use the symbol for ray so I know you're referring to a ray, not a segment or a line. Okay, lastly, let's look at part C. Which of the rays in part B are opposite rays? Well, here, if we look at endpoint E, I could head to the left towards point D for ray ED, and I can start at point E and head to the right for ray EF. So rays ED and ray EF are opposite rays. Pause the video and do you try number 2. Ray EF and ray FE form a line. Are they opposite rays? Explain. All right, so let's look at ray EF. So here's ray EF, and here's ray FE. Notice that they do not have common endpoints. Even though they form a line, they overlap here. So because ray EF and ray FE overlap and do not have the same endpoint, they are not opposite rays. A postulate or axiom is an accepted statement of fact. They are the basic building blocks of the logical system of geometry. We're going to be using logic to prove general concepts throughout the course. Let's look at postulate 1-1. It states that through any 2 points there is exactly one line. So here, if I draw a line, I can only intersect 2 of those points at a time. An intersection is the set of points 2 or more geometric figures have in common. So here, intersection of a line, here, an intersection of planes, and here is the intersection of a plane and a solid. Postulate 1-2 states that if any 2 distinct lines intersect, they intersect at exactly 1 point. So here, line AE and line DB intersect at point C. Postulate 1-3 states that if 2 distinct planes intersect, then they intersect in exactly 1 line. So here, plane RST and plane WST intersect here at line ST. In example 3, each surface of the box represents part of a plane. What is the intersection of plane ADC and plane BFG? Well, here's plane ADC and here's plane BFG. The intersection of those 2 planes would be the line where they touch, which would be line BC. Pause the video and do you try number 3. Okay, here are the 2 planes that intersect at line BF. So plane AEF and plane FGC intersect at line BF. All right, the reason you only need to find 2 common points to name the intersection of 2 distinct planes is because it takes 2 points to name a line, and a line is the intersection of a plane. Postulate 1-4 states that through any 3 non-collinear points, there's exactly 1 plane. Think of the feet of the tripod as points Q, R, and S, and the table as plane P. Notice that the legs of the tripod sit perfectly on that table. Okay, what plane contains point N, point P, and point Q? Well, we know this is the plane, so plane NPQ. And if we are to shade it, here's NPQ, and we'll shade it right there. For part B, what plane contains point J, M, and Q? That would be plane JMQ. And if we're going to shade it, here's J, M, and down here is Q. Notice this plane sits on the diagonal. Pause the video and do you try number 4. Plane LMN is the plane that contains points L, M, and N. And for part B, there are 2 lines that are coplanar with line JK and line KL. Here's line JK and here's line KL. If we finish that plane, here it is, you see that line JM and line ML are coplanar. Now's your chance to shine. Complete the lesson check and then go to the next slide to check your answers. Okay, how'd you do? If you can get the challenge question, you really get this lesson. Take a look at the learning goal again and the scale. Where are you now after we've completed the lesson?